Welcome everybody to example 3 on page 87 of the workbook. Okay, this is the first of a couple of examples that we're going to do illustrating how L'Hopital's rule works. Okay, and in this problem, they're asking us to calculate the limit as x approaches infinity of e to the x over x cubed. And I want to first start by reminding you that before we do L'Hopital's rule, we need to check and make sure that our limit has the proper form to use it. So that amounts to asking the question, how do the numerator and the denominator behave as x approaches infinity? Well, notice that both e to the x and x cubed get big as x goes off to infinity, which tells us that this limit has the form infinity over infinity. That was one of the 5 indeterminate forms that we mentioned at the top of this page. So that means that we are free to use L'Hopital's rule to help us calculate this limit. Okay, so we're starting with a limit that looks like e to the x over x cubed. Okay, and then one piece of notation that we often use to indicate that we're using L'Hopital's rule is to put an h above the equal sign. That just means we're going to use L'Hopital's rule. And the rule says, again, we're going to take the derivative of the top and the bottom separately. So the derivative of e to the x is still e to the x. The derivative of x cubed is 3x squared. Okay, and so we look at that new limit and ask, what's going on now? Okay, well, notice that as x approaches infinity, e to the x and 3x squared still both approach infinity, so this limit still has the form infinity over infinity. So what do we do? Well, if the limit still has the form infinity over infinity, we can just use L'Hopital's rule again. Okay, so we're going to take the derivative of the top and the bottom. Derivative of e to the x is e to the x, and the derivative of 3x squared is 6x. But notice that that still has the form infinity over infinity. E to the x and 6x both get big as x approaches infinity. Okay, so we have to do it again. Okay, so if we take the derivative this time, that numerator is going to just stay the same. So we're taking the derivative of e to the x, and the derivative of 6x is 6. And this is a good sign because notice that that denominator now, that's not going to go off to infinity, which means that this limit no longer has an indeterminate form, which hopefully means we can calculate the limit without having to use L'Hopital's rule again. All right, so let's think this through. So as x gets really, really big, okay, the top of the fraction is going off to infinity. The bottom of the fraction is staying constant at 6. So we have a fraction where the numerator is getting really, really big, and the denominator is staying constant at 6. Okay, what's going to happen to a fraction that behaves that way? Well, if the numerator gets really, really big and the denominator stays constant, the entire fraction should get large, should go off to infinity, and that should be our answer here.